Hey, Dark, how's it going? Audio levels here. Audio levels. Wow. Fix that. I can fix that. That sound. Right. I think it's a little better. At least on the YouTubes. Let's see how it sounds on the Twitch. Found some what I hope to be DMCA free music that I can play on YouTube at the same time I play on Twitch. Yeah, I think we're good. I'll just have to be careful. If I do end up like playing actual music, then I'll need to make sure YouTube isn't receiving it. That's a lot of points, sir. That is a lot of points. We need to like, do I need to figure out how to set stuff up for you for that? Let's see here. You can enable channel points, customize point display. Oh, Drill, what are you doing? Hello, world. Hello, San Diego. All right. Ouch, my cat is attacking me right now. He is going insane. Dude, it's literally the start of the stream. Could you not wait? Look at this. There he goes. He thinks I'm getting up for him. That's what he thinks. How's it going, chat? I have an itch I've been wanting to scratch ever since we looked at that Vulkan scene graph code base, and it has my mind erasing. And I think I want to tinker a little bit this evening with some C++ and maybe a little bit of benchmarking to do some compare and contrasts on different techniques we can use to handle our data. That's the plan. Figure write some C++, play around with it, see what we learn. Ooh, that's a great question. Should I show you guys Briarthorn today, or should I save it for Monday? Trying to think. I don't think I'll have more time between now and Monday to do anything else with it. So maybe I can show off Briarthorn a little bit. I'll probably show off Briarthorn a little bit. It's all like visual stuff. There's still no like real gameplay. But let me. Oh my God, my cat's back. Hey, what are you doing, Trill? Hey, come here. I've been letting my cat outside, and now he is just all about being outside and coming to get me to let him outside. He just doesn't care about me anymore. And yeah, like, do you guys see that? He's just sitting there, like, kind of waiting for me to help him out, to do what he wants me to do, or to do what he wants to do. Like, I am on his dime. It appears, right? Which is just ridiculous. Freaking cat. Let's see here. Where? All right. I'll show you guys a little bit of Briarthorn. Is it this one? Oh my God. Maybe that's a little too much Briarthorn. Hang on. So hopefully, you guys can kind of start to see the vision here. Oh yeah. So a bunch of stuff has happened, right? How do I make it so you guys can see it and I'm like not covering it up? You know what? I'm gonna hide my face for a sec, I think. How do I let me do that? I'm gonna show this. Yeah, let me do this. Okay. Nope. Why? If I do this, I have to like get this figured out. Okay, so now I have it maximized. All right, do you guys see Briarthorn? I'm assuming you see it because I see it. So, oh, you can't really. Oh, you can see my mouse. All right. So hopefully you guys can kind of see the vision of what I'm going for. So the general idea, think of just any kind of roguelite, right? Where you are dropped in a level. You're dropped in a level of enemies, right? So, good morning, Think. Um, for me personally, the thing I like about roguelikes is combat and progression. I really like figuring out the math of maximizing stats to do the most damage or to be the most stealthy or to be the most tanky. So over here on the right, you can kind of see some of these. These are essentially like equipment slots. So I'm picturing now, caveat, all of this is subject to change, but I am picturing being able to maybe between missions, being able to purchase items to equip, um, add loadouts like missiles, bullets, I don't know, defensive stuff like drones or toad decoys, flares, things that like protect you. I mean, this can even be futuristic, right? It could just be like a deploy an energy shield type of thing. This doesn't have to be realistic. And then this kind of shows what your class is, what you're currently playing. So you are the swarm. You're a collection of drones that move together in a cluster. And then this is kind of your playing field, right? And then up here at the top, which is kind of hard to see right now, um, and this is all obviously subject to change. I might move the location of this, but this kind of shows you like what you're dealing with at the mission level, what you've managed to find. So these are like all the different tracks that are out in the world that you have to deal with their health bar. So as they take damage, they'll get red. You know, this is like any other RPG style game like Baldur's Gate or whatever. This is kind of the enemies and their and where they appear. So here I am steering, right? Zooming in and out. We have the trail effect, so you can this gives you a little bit better idea of where you've come from. So there is a little bit of motion to the game, so you're not just staring at a screen of blue and you don't know where you've been. So this kind of lets you know, like, oh yeah, you are actually moving. Now this stuff up here is still very much placeholder. But I did add some text to show like how fast you're going. So if I press forward or right trigger on the joystick, you start to accelerate. And as you're accelerating, you're finding new tracks out in the world that are starting to appear. I think I need to come up with a way to maybe show that there is more stuff out in the world. Um, that way you know like where to steer the aircraft to. Over here on the left, I literally put this in today. But over here on the left, I'm thinking of putting just more gauges, things like fuel, because we talked about maybe needing fuel, maybe your engine RPM if we do anything like that, or your throttle and your brake, stuff like that, right? And then here in the middle, the big view is obviously where you would want to put your maybe you don't. You get to decide as part of what this game's going to be. But this is kind of like your playing field, right? And then to the right here, this so in the middle, this is like the attack display. The idea is you want to be able to see more in front of you so you know what you're dealing with and what you're going to be shooting at. And it's like a little bit of a closer zoom in. Whereas on the right, this is your situation. So you can see everything that's going on around you. And then maybe as your radar picks things up, you'll see that you get an idea of what's actually out there that you're dealing with. Hey, is that a friend? Is that a foe? Is that a cluster of drones? Is that a missile coming at my face that I need to deal with like a defensive maneuver down here? That kind of thing. And then depending on like maybe your compute or your sensor, maybe when you're out dealing with something over here, you might forget that there's somebody over here and you need to steer back around. But maybe depending on your upgrades, your talent tree maybe, it will remember what this is longer and be able to keep that there, right? So that kind of thing. So I really want to make it important about like what upgrades you choose to purchase so you can know what you're dealing with out in the world kind of thing. And then on top of that, with the idea of being able to like drag and replace, check this out. If you choose to move this guy to a smaller square, it becomes simplified. Now it's kind of like a mini map, right? So I thought that was kind of cool. So because it's a smaller square, you don't want to be cluttered with a bunch of detail, but you can move it over here so you just have a general idea of where things are at. And then if you ever did need more detail, drop it over here, right? So that's something else I'm playing with. The idea of being able to like expand to get more detail by moving stuff around on the display. That way you can kind of choose your layout and what information you decide is most important for you to beat the game. So that's kind of where I am coming from with this. So right now it's still very much visual, not a lot of gameplay logic itself. A little bit of like radar detection stuff going on here. Um, so still kind of playing with that. Oh, I do have cursor lock on now, so this cursor will follow the track. So you can kind of picture, I don't know, maybe your compute ability is high enough level, or you get a good upgrade item that lets you scan what you're tracking, and then maybe you get additional detail on weaknesses and strengths of what you're targeting, so you can better pick which weapon to shoot at them, kind of thing. And I'm also like, I do plan on making it like a large battlefield, so it takes a little bit of time for them to get to you, or a little bit of time for a weapon to reach you. That way, it gives you time to think. Like, okay, there's a guy out here. Here's his detail that pops up. What's the best way for me to deal with him? Let's see. He's very weak against explosives or blunt force trauma, if you will. So what I need is a missile that doesn't necessarily have to impact him, but a missile with like a blast damage or fire damage. So I'm going to go pick that. He's targeted, and then I don't know exactly how I'm going to set it up yet, but it might be like, set your weapon to launch or set your weapon to armed, and then once he's in place and you're ready, you hit the button and fire. And you've made that, like, you've had time to make that decision, because this guy is still 80 kilometers away, right? So he's still like, actually technically he's still pretty far away. And then another thought I had was, so even at this 10-kilometer range, you will eventually get some guys who are on top of you. At this closer combat, now we're talking like more bullets or more like rapid fire weapons, drones, that kind of thing. So maybe I have a zoomed in display specifically designed for close combat. And maybe we have a mission that's all about close combat. So it's like, okay, it's time for close combat. I'm going to grab my close combat display, drag it in the center. Now it's time for close combat, right? So that's the general idea that I am playing around with here. Still a metric crap ton to go, because this is all visual. I have no idea what the gameplay logic is really going to look like yet, so that's what I need to start playing with here soon. Firing weapons, picking up items. So I do have a little bit of an item pickup here. It doesn't do anything. It's just visual. I can't even like drag and move it around, because anytime I do, it moves the whole display. So I got to think about that too, right? Like, how do I what's the best way to move some of these displays, especially if I want to be able to like drag and drop items or equip, or maybe I don't. Maybe this loadout is like mission planning, right? So between levels, you get like a pop-up that appears in the center of the display, and that's where you're going to purchase your weapons that you're going to use for the mission. Maybe you get a mission description. Here's what you're dealing with. Here's what's available for purchase. Here's how much fuel you might need, or here's the recommended fuel. If you want to go below that, okay, it's going to be more difficult. And then this is like a static loadout. So this is what you have for the duration of the mission. So that's kind of where things are at. But I do really like the ability to just like drop it into a smaller panel and have it be like your mini map. And then also the idea of some panels you can't drag it into, so it won't let you drop it in, right? That's where that's coming from. And even the debug display supports both the square based portal or the horizontal based portal, so it supports both. So I'm also toying with the idea of these displays having different states they can be rendered in. I don't know if I did it for this one. I kind of did. It's not very good. This one's definitely going to change. I just put this here to fill up space. But yeah, that is where Briarthorn is as of like a few hours ago, because I basically spent all day yesterday and most of this morning playing around with it. That's where we're at there. Cool. Now, just for general C++ stuff, I wanted to play around with an idea. Micro benchmarking of, because we kind of had this conversation with Vulcan SceneGraph the other day, like how are they handling these pointers? This guy ended up creating his own custom allocator. So I kind of want to set up a little project to explore some of that and what it might take for us to do it. Because I've never personally, in my entire career, have I ever had to write a custom allocator. I honestly don't know what like the standard way of doing that is. I think there's some newer ways of doing it now using a PMR memory resource object. No idea. I would have to learn it. So I figured let's create a project and let's try it. Let's just do it, you know? Let's just go for it. So I'm gonna create a folder here. Call it, what do we call it? CPP benchmark, I think. Entity. No, I'll call it entities. All right, so let's open folder entities. USA. Oh my gosh, guys, the World Cup. So a little bit of background, a little bit of context here. I played soccer since I was 3. I started playing competitively when I was 9, and I'm trying to think. I played for at least what we call here in America what is called a select team, a travel team. So like a team that is actually designed to compete and succeed and travel. Traveling team is another way to do it. So I started doing that when I was 9. By the time I was 14, trying to think, this would have been 7th, 8th grade time frame. Yeah, I think so. By the time I was 14, I was on one of these teams that and I grew up in a small town. So this team was really kind of made up of kids either in the small town or neighboring cities. And we had a coach that had a motto for us. If we were ever to lose, it was not because we were out of shape, you know. So if that tells you anything, she ran us to the ground. But when we actively competed in during the season and in tournaments, we won. We won everything. We won every time, and it was unbelievable. It was nothing I had ever experienced up until that point. Uh, so like our soccer team was insane, and now we played within like a I don't know, like how many counties? I don't even know if you guys know what counties are. That's a United States thing, I think. But so United states are made up of counties, and counties typically have maybe one, two, three cities, towns, townships in them. Uh, so we played in an area that was maybe that that took up a quarter of the state, I would say. And so the quarter, so basically imagine like a square state, and we played in like the bottom left region of that state. And so we never lost a game. So then eventually we went to another state to play in like a World Cup style tournament. And in that World Cup style tournament, we ended up placing like 16th in this tournament out of I think 72 teams. So basically, what I'm getting at is I grew up loving soccer. I played soccer year round. It was my favorite sport, and I was pretty decent at it. Played in high school, varsity, was going to play in college, but it was a little cost prohibitive, so I ended up not playing in college. Um, all of that to say, I have been watching USA play World Cup soccer for, well, since like 94, 98. I think I vaguely remember the 94 World Cup tournament. 98, I think, is when France won. But I've basically been watching since then. And I grew up watching like the Donovan and Dempsey era of USA, where we did pretty decent in 2002. I think we got like top 8 or something like that. That game Friday, I think that was the best I have ever seen the USA play, at least offensively, especially that first half. I just unbelievable. Dest, Pulisic, McKennie, just like the way we moved the ball, it just blew my mind. I couldn't believe it, and I went into this tournament being fairly apprehensive about the way the USA was going to play. So I am super stoked to see how this is going to turn out. But yeah, the USA did phenomenal. I cannot wait. I cannot wait for their next game. Let's see. Oh yeah, I love it. It's my favorite sport, and I don't watch it all that much. I only really pay attention to the World Cup stuff or the national teams. I don't really pay attention to like MLS or even the Premier League for that matter. I'm aware of them. I catch highlights every now and then. Okay, so I have a folder open. We're gonna get this project set up to I think get some micro benchmarking library up and running so that I can test my my thoughts, because I have a couple of thoughts on how I want to do this. I don't think we need anything crazy complex here, so let's just do like entities dot benchmark dot cpp, I think. And then of course we're going to need a CMake list. Then we're also going to need VC package. We always need our package manager. Yeah, my understanding, because again, I don't pay attention to all the teams. My understanding is our real competition is going to come from Turkey. It sounds like Turkey has a pretty good offense. Well, I will be curious to see how that plays out. But one game at a time. I mean, even if we lose, if we can play as good as we did, I'll be happy, because I just was not expecting us to be able to move the ball around like we did. Just unbelievable. I gotta remember how to do this. Git submodule add. Is it this? Is it this? Not a Git repository. GitHub.com. I always forget how to do this. I am doing that. Am I crazy? Git some. Oh, this repo isn't. I need to do a git init, don't I? There we go. Okay. So now I do a git submodule add. I don't need a specific version. This is just for tinkering. I don't need to like get the setup perfectly or anything. Need our VC package.json file, also that we can pull in our micro benchmarking library that we're going to use. Copy from Awin. Entities. We don't really have a website. This. We don't need this. We are going to use a library called Celero. Maybe Gtest. I don't know if we need that or not. We have benchmarks. All that looks good. Is that all we need? I guess I need to actually set up a project here. Let's call it Entities. Benchmark. What else? Add executable entities benchmark. Except that's not how we do it. And we'll need to do like a link library as well, but I'll wait for VC package to actually tell us what that is. What else do we need? What else do we need? No kit selected. Will this just work? Can I just say use Visual Studio? Find out. I don't need to set up presets or anything. We're just doing this locally here for fun. Ooh, unless I do need to set up presets. No CMake minimum required. That's fair. Calling me out. Okay. I'm sorry, this music doesn't work for me. I gotta find another one. What's another DMCA? Free. No, there is some. What does this sound like? I was looking for, I'm trying to find some music I can play on both streams. We'll see how it works. But if it doesn't work, then YouTube will just have to suffer without the music. Or I can just start singing for you. Ugh, we don't want that. Okay, so that configured. Does it build? Yeah, it shouldn't build. There's nothing to build. Okay. I'm so used to doing this with presets. I need to define the tool chain. So I wonder where I put that. Set CMake tool chain file. Is it here? Why is this not working? Wonder if I have to do it here. How it works? CMake toolchain file. See if that works. I have not used CMake presets in a long time. In fact, I'm trying to think. I think the last time I didn't use presets was before VS Code, so I actually don't know how VS Code sets all these variables up for you, and it looks like that's how. So you can define a VS Code setting for the CMake project to define it here if you want, because now it's pulling in dependencies. Huh, weird. Guess they got fed up waiting for me to let him outside. Okay, so this is what we need. Find package Celero, target link library Celero. So we do this. This is a CMake tool extension. If I wasn't using the extension, I would just be using the CMake GUI, or honestly, I could just run it on the command line. That's something else I could have done. So if you're not using VS Code, for instance, and you don't have this, then it would just be a matter of doing like CMake-S for source, current location, -B for build, and then -D for the options, CMake toolchain file equals, and then you would pass in the path to the vcpackage.cmake file. That would have accomplished the same thing. Wait, did that? Oh, excuse me. Did that configure? It configured. It didn't build. That's because I don't have everything in here. Okay, so I don't remember how to use Celero, so I need to look it up. It's probably been a good 5 or so years. There was an example. Okay, so include Celero.h. I can do that. The capital C? Celero main is needed. So let's do this. I guess let's see if that will compile. How's it going, Broken? Okay, that compiled. Good. And it's located here. Entities build debug entities. Let's make sure it runs. /build debug entities benchmark X. Okay, perfect. It's running. We are where we need to be. Except I need to make sure we can read this as a table without the word wrap. Okay, cool. That works. Finally made it. Nice. So that worked. We're still dealing with this IntelliSense nonsense. Dang it. What did I have to do? Compile commands, I think? Because I'm using the ClangD extension, right? ClangD extension. compile commands. So what is that? Settings, CMake, enable, compile commands? Is that right? I don't remember if that's I'm gonna look at Alwyn here real quick, like CMake set export. That's what it is. I need CMake export compile commands. So we'll try that real quick and see if oh, I also have to tell Clang D where those compile commands will end up being. If we look at my Awin settings, basically have to do something like this. Something like that, I think. Have that. So then let's delete the build folder. All of this just so I can get IntelliSense working in VS Code. You know what, Jabir? I don't know why you're here either. I don't know why anyone's here. It's ridiculous is what it is. Alright, so let's build this real quick. See if that worked. Problem frickin' not solved. Let's go. Problem solved now? Problem solved now? Day 9, day 10, waiting for that monster sponsorship. Just hit me up anytime now. Okay, so I'm not getting the red squigglies of death anymore, but I'm also not getting the right click to go to definition. But that's okay. I just didn't want the red squigglies of death. Okay, so we need a baseline and a benchmark is how this is going to work. Baseline, benchmark. So if I do baseline of, I gotta give it a name, right? So entities. And this is the name of what we're testing. Okay. So the name of the group, the name of what we're testing, we just call baseline. The number of, is it samples and iterations? Something like this. Make sure that compiles. Okay, that compiles. So then we need the benchmark. And if that compiles, okay, sweet. Let's write some C++ and figure out why things are slow or fast. So, I guess the question now becomes, I need something that will, like, set up my entities, allocate the entities, and I don't want to necessarily measure those allocations right now. I just want to explore iteration, I think. We could do allocation benchmarking as well. And I think this library has something for that. Kind of like Google, kind of like GTest, it has like a fixture. Threaded benchmarks, that's kind of cool. It is fixed. No threads or test fixtures. Fixed measurement benchmarks, well, typically measures the baseline time. You can also specify a fixed measurement time. This is useful for measuring performance against a real-time requirement. Oh, cool. So you can be like, hey, I need 100,000 entity iterations to, I don't know, run at 1,000 hertz and add that as a benchmark requirement. User-defined measurements. I think... No, this isn't what I need. Fixture, here we go. Now add it to your regular seller. Is this the first time we've seen this? Is there an example of like actually how to use this? Measuring benchmark execution time takes place in the test fixture base class from which all benchmarks are written. Okay. Not really, but that's okay. But this is what I need. User-defined measurement. I just want to initialize my entities. Can I do that before I run them? Can I do something like what am I trying to do? Const auto entities equals lambda. Just initialize the entities here, and then in here iterate over the entities. So what do I need? I'm going to need a vector for sure. We're going to need memory for sure. We're also going to need like 'Nope, this isn't working either. I want something a little more chill. Like the beat just keeps going over and over again. I need something else. We need something else. "12 hours of DMCA free and copyright free music for Twitch streamers." Let's go. Yeah, I'm trying to find something a little slower paced. Okay. Oh, that's what we need. We need an entity. We also need some work. But we don't want to measure the work. We just want to measure. Maybe we just do like, we call it update. And this, I think this, honestly, this might be our baseline to test against. Because nothing is probably going to be more performant than this. So our baseline here is oh my god, this isn't it. This isn't it. No. Let's call this const auto baseline equal standard vector of entity. I think that's all we do, right? Because this is inherently initialized. Like, this creates a million entities. A million a lot. I feel like a million's a lot to start with. Screw it. So in here then, what we want is entity update, and we want to not optimize. Celero do not optimize away, because this update function doesn't do anything. We really don't want... is this the best way to do this, actually? How does Celero? Are they passing in a function? Okay, so they pass in a function. Okay, so I really need to not optimize the function away, I guess. like that. I think that's what we want. And then here, as a very, very simple comparison, I think there's a way to actually... I'm trying to remember, is it not standard fill? What am I thinking of? Standard fill? Yeah, same idea. Not a big deal. All right, so this one's going to be iterate entities. And then here, we do this as well. Now, I'm currently building in debug, I think. Oh, it does not like something I did wrong. No matching overloaded function found. Could not deduce template argument for function. Am I doing this wrong? Oh, can I not call optimize on function? Do not optimize on functions. Okay, that's fair. So I guess I do need to. Let me try this. Celero. Not optimize away. Celero, doing something wrong. This is all the micro benchmarks done. Take a look. This might be what I need to do is a fixture. Initialize my entity. Do it this way. Oh, yeah, that's right. Okay, so, yeah, this is what I want. So one of the things you can do with this library is you can set up incremental benchmarks. So 1 entity, 100 entities, 1,000, 10,000, 100,000, a million. So this is really what I want to do. Problem space. Clear out. So yeah, this is what I need. Okay. Okay. That's what I need. I was doing this wrong. I'm doing it wrong. I do want that. So I need this fixture. Nope, that didn't work. Why did I think that was going to work? How do we pass this fixture in? We give it a name. Testing. Then name of the fixture. Okay. This will be like iteration versus allocation. This is the fixture. That's what we need to do. So this will be entities fixture. Only right I've done a debug. No. Don't you start that. We do not profile and debug. Ever. Okay, so for loop, fixed time. Gonna be our baseline. These. I need this guy. Oh, setup as well. Okay, so I need setup, teardown. I need all of this. My God, not having a I gotta have my formatter. Hang on. You can never write code without an auto formatter anymore. It's not a life I ever want to live again. Let's see. Clang tidy. Not clang tidy. Clang format. I don't have format on save. Please, format. What? It's not formatting. Format document with. Playing format. There we go. No. Not working. Editor, format on paste. Dang it. Save. Alright. Whew. I was about to freak out. Dude, Trill. Like, I'm in a neighborhood. And the neighborhood, like, it doesn't have sidewalks or anything. Cars come and go. So it's, I wouldn't say it's a, like, a relatively safe neighborhood for pets to just go wandering. So Trill, I let outside my backyard, but he does get through like an opening in my gate. He was gone all night. He, like, I checked at like 9:30, didn't see him. 10:30, didn't see him. 11:30, didn't see him. I was up till like 1:30 in the morning, I think, working on Briarthorn. He never came back. So I was like, all right, well, I guess that's that. And so I went to sleep, and I woke up the next day, and I checked outside at around, I think, 10:30 in the morning. He's just chilling. He's on the back porch on the, I opened up a lawn chair for him, and he's just hanging out in the lawn chair. He's cool. Not a care in the world. Little twerp. Experimental values. So this is where I need to define my problem space. Total number of tests. I don't think I need 12. Build a nice graph. We made the number of iterations decrease as the size of our problem space increases. I think this is fair. Number of tests, though, what is this? I think... I'll leave this alone for now. We'll see. But this is where we're going to allocate our entities. So this is what we need. Our standard vector entity baseline standard vector unique pointer entities entity unique. This is kind of what we did last time, right? Vector, standard, shared pointer, entity shared, that kind of thing. Whoops. What did I do wrong? Autocomplete's getting a little bit annoying. Okay. So then our experimental value. Okay, so this is the number of entities. That we're going to allocate. That's basically doing this baseline dot resize. Reserve? Resize? Resize. Because then that will automatically keep this data and then delete anything. But here, what we need to do... Ooh, I'm curious... Okay, so this will... Okay, yeah, this will clear everything. Yep. Okay, so this gives us our entities. All that makes sense. So now this becomes entity iterate. I think we need to do an underscore F. Entity iterate baseline. Okay, yeah. Iterate baseline or F. The fixture we are using, entities fixture. Then I don't think these values matter because we're using get experiment values. So I don't think these. I just set these. Okay, so entity iterate baseline. So this now just becomes this guy right here. So now I can do this. Baseline. This becomes iterate entities fixture. Becomes unique. Shared, and I think I can still do 1 and 1, and then I will adjust the experimental values. Cannot access private members declared in fixed. That's fair. Cool. Okay, so that's in debug. We actually need to do this in release because we do not benchmark in. Okay, so we need to run entities release entities benchmark. All right, so this is the results. Now, keep in mind, we're only doing a couple of entities, so we're not going to really see anything crazy here. Except whatever's happening on these two lines is 2 times slower than the baseline. That's weird. And I think this is iterations per second and then how much memory is being used in bytes. That's 765,000 bytes? Is that a lot? It seems like a lot. Okay, so problem space. So this is how many entities, how many iterations. So I want to bump this up, I think. So we can, I mean, we can still do this. Isn't there a way to get, I'm going to run this, hang on. I'm going to run this in my PowerShell window to see if there's color. I thought there was a way to get color in this. I don't know if it's a VS Code limitation or what. Dev entities /build release entities benchmark. Okay, so there's no color here. I wonder, is it? I gotta see if there's like a colorized flag. We can save a results table to a file. Save as a JUnit XML formatted file. I really thought you could color this. I thought wrong. Okay, so let's bump these numbers up. We can problem space iterations. Okay, so problem space iterations. So instead of doing it like this, problem space iterations, what we can do instead is just manually define this. So, for one entity, we will run it, go figure, 1,000,000 times. Right? That will for sure get us the best possible average, or like the best possible measurement. But the issue is the more entities we have, the slower it's going to come, so we won't be able to, we won't need to run it as much. So then we do 10, 100,000. Okay. 100,000, 1,000. I don't need any of this. Ooh, I screwed something up. Why is this not tabbed over? What did I get wrong? I have too many closing parentheses. Okay. Run it again. Okay, so here you go. What? Oh yeah, that makes plenty of sense. It's interesting that I'm getting the same amount of RAM usage. Oh, I wonder if this is the RAM usage of the total application. Because we don't see the RAM usage start to grow until he hit 1 million entities. We'll need to keep an eye on this. But this might just be measuring RAM usage of the application. But that's not really what I care about. What I care about is iterations per second. Sample size. Okay, so sample needs to go up. Sample needs to go up. We do have to define that. So I'll do like, I'll just say 100 by 100. Because it's like, it's unable to get a good measurement. And so what sampling and iterating does is, like, if you have something that is imperceptible to measure individually, so it's just like it gets called faster than the clock can measure, then you need to call it more times so that you can get a measurement of, say, 1,000 calls, and then you just take the average of that. So that's why I think we were seeing 0 for some of these things. Here we go. No, we're still seeing 0. Iteration. I'm worried it's getting, like, optimized away. 0 iterations per second. I wasn't able to do, like, okay, so I think I'm just gonna put some work. What we need to do. It is kind of crazy, though, that we can basically get 333 million iterations per second for 1,000 entities. Yeah, I'm not 100% sure why it's struggling to measure this right now. I'm worried it's just straight up like getting optimized out. But we can try for sure. I don't remember. Okay, it's not this one. The larger this value becomes, the longer our benchmark takes, but the more accurate our, or maybe not accurate, the more precise our results will be. Taking longer. Yeah, what the hell's going on here? It's happening every time. Suspicious. Am I setting this up wrong? Let's just bump these up. N to 10, 100, 1,000. I'm just gonna. 1 million, 10 million. Try that. Understand. This doesn't do anything. Also, you're also studying C++. You are learning arrays and 2D arrays, if I understand what you're saying. What would I suggest to prioritize for AI? That's a great question. I do think any language, especially like a scripting language, whether it's Python, JavaScript, really any scripting language is going to work really well for AI, I think, just because there is so much, especially Python. Python, I think, is like one of the most popular programming languages in the world right now. So there's just more data that it could train on. Now, the caveat there is there's probably a lot of bad data it could also train on. But I would think any scripting language would work really well with AI. And then if you're like doing and not just like auto-generated code, but on the other side of that, if you're actively doing like AI and machine learning, then Python for sure has a bunch of libraries to do work like that. Okay, so we're getting somewhere here. We're getting somewhere. So I think the issue is, yeah, I think the answer is the iterations. I don't think I am running enough for it to have a measure. So I'm doing 10 iterations on a million entities. Am I doing that right? Which I knew. Gonna get rid of this one. Ooh, that's taking a second. Done this so many times over the years, I don't know what I'm running into. Do this. I'm doing something wrong. It's got to be like optimize. What happens if I do a little bit of work? I'm just going to do a little bit of work. Something like that. Do not optimize is not a member of Celero. What is happening? Is it do not optimize away? Yeah. See if that has an impact on what we're seeing here. It's very possible, especially now that it's like now it's not even running. I mean, it's running, but it's running like, oh god, is that 10 million? Oh no, I may have done too much. I'm doing 100 entities over 10 million times. I have gone too far. I have gone too far. In my quest for trying to figure out if I could, I never stopped to consider if I should. Like what I did there? All right, so now we're down to 1,000,000 iterations, which still seems like a lot. Ooh. Hey, okay, here we go. Something's happening now. Now we're getting somewhere. I don't want it to run this long, though. I don't think I need 1,000,000 iterations times 100 samples. This is basically means I'm iterating over 100 entities 100 times 1,000,000. Yeah, I don't need that. I don't need that. Abort. That's still too much. Let's do that. I want something we can look at like today. There we go. Now we're getting somewhere. There we go. Now we're getting some data. Ooh. Still not getting... What is happening? Something else is probably getting optimized. I'm gonna try the... Oh my god, guys. I figured out what's going on. Are you kidding me? Not a single one of you called me out on this. Of course it wasn't being measured. And of course the memory wasn't increasing. I never allocated. And so it looped over empty. And so we never called make share or make unique. Son of a biscuit. Okay, so let me, I'm going to comment this out because I'm really not trying to measure like work being performed. Let's see what happens now. I blame YouTube chat as well. In fact, as punishment, YouTube, I apologize, but I can't take it. We're switching back to my music. So YouTube music, you should now have no audio. I'm gonna verify before I kick on mine. All right. No music. All right, no music. I apologize, YouTube. I tried. I'll do a better job next time. I'll see if I can find some music that actually that like that music just gets a little repetitive. I need to find some like non-repetitive music. What am I in the mood for? I kind of want to listen to that yeah, we're doing Run Londinium. Yeah, here we go. Is this still running? Holy crap. Wait, it's still not. What is happening? Am I screwing something up here? We resize. Then we... Then we dance. All right, I'm gonna go use the bathroom real quick. It's also getting really warm in this house, so it makes me think my AC is off. So I'll be right back. All right, I let Trill outside. Okay, so what is happening here? For a couple of these, I mean, we're seeing the RAM actually. Okay, so now we're actually seeing memory increase, which makes sense. Okay, so the iterations. Yeah, it's also taking longer to run. So the iterations can drop some more, I think. Maybe I dropped the samples. I don't want this to like. Oh, I'm doing too many. I don't want to do 10 million. I wasn't trying to do 10 million entities. How many bytes is this? This is like 3,000. 26 megabytes. Makes this 254 megabytes. Also got to make sure I don't accidentally consume like 60 gigs of RAM. Because this stream would come to an end really quick. I'll tell you what. You click. Yeah, I can. Let's for now. Let's turn this one off. Okay. So now I just need to figure out what in Tar Nations is happening here. Are we still actually getting optimized away? Am I calling the wrong thing? Entities unique. Fixture shared. Entity shared. Let me try this again. If you need help with a programming thing, I'd prefer to do it on stream. I don't mind helping people on stream, assuming I'm able to help. Okay, so yeah, I think that's what was happening. I think we were getting some optimizations removing our code from us. Now we should have some good baselines here. So, with a vector of entity of size, what, probably 4 bytes. Yeah. We are looking at about 2,000 frames a second for a million entities. Not bad. But then for our unique and shared pointer, we're looking at about 750 frames a second or 284 frames a second. And I think we kind of talked about this, right? Like, why, when we aren't taking any copies of a shared pointer, why is the shared pointer twice as slow to iterate? Because under the hood, we're just calling update here. We're not doing anything else special. Well, as it turns out, how the shared pointer, which is a slightly larger object than a unique pointer, how it fits in the cache, probably means that we have to go and fetch more cache lines in order to continue the iteration. Well, no, not reference counting. Remember, we're not copying anything. So there is no reference counting. Because the only thing this benchmark is measuring is what happens inside these scope braces. So anything that's happening up here is outside the measurement before each run. So the only thing we're measuring is iterating over entities and calling this update function, which increments a count. I wonder. Can I do this? Does that do anything? I really don't want to have anything in this function if we can. I do this. Let's run it. See what happens. Interesting. So now that the update function isn't doing anything, our iterations become closer together because there's no like data to read. I don't think. I'm kind of guessing here, but I'm okay with having this in. Let's put that back in. I think this is a little more interesting to look at. Yeah, that's just like the shared pointer is just straight up slower to iterate. Now the question is, if the answer is it's slower to iterate because it's larger than a unique pointer, then what we should see is with fewer entities over here on the left, we should see similar performance. So this is what 1.6. This is also 1.6. This is 1.7. This is 1.4. So that's close. I would say that's within margin of error. Even here, 124,000 versus 154,000. Now we're starting to see somewhat of a difference, and this is with 10,000 entities. And then we're seeing an even bigger difference here, 14,000, 15,000 versus 10,000. So it does appear to be the more entities there are, the more RAM it's consuming. Yeah, that's just straight up slower. Like I said, most likely due to the size of the shared pointer. Now, if we make the entity big enough that the size of the shared pointer won't be as big of a deal, that shouldn't matter though, because you're iterating over the pointers themselves. All right, so this is all well and good and cool. The thing I wanted to try and explore, because it's something I've not done. I don't know if I have enough time to get it all done today. Is can we get our pointer iteration, which is currently about half as quick as the baseline? Can we improve this? So that's kind of like what that Vulkan scene graph library was doing, right? They had some kind of like custom allocator that I think made sure the memory they were allocating stayed within a pool of memory, which I think made it a little more performant because the memory was closer together. Whereas right now, under the hood, we're calling, make unique, which calls new, which calls malloc, which invokes the heap. That memory might not be as pooled as we would expect it to be. So we could write our own custom allocator to have complete control over how the memory is allocated. I've never done that. I have not done a lot of memory manipulation over the years. because everything I've done has never needed that level of performance. Like, even with unique pointer, we're still talking a million entities, a million objects of iteration that can still run at 900 hertz. Like, usually when in code bases I've worked on, we're dealing with like thousands, maybe 10,000, but thousands. And look at the performance there. It's it doesn't matter. Like, a lot of the time when it comes to iterating over logic, there are other bottlenecks that are more present. Maybe you are returning a copy of a string over these 10,000 entities. That gets really slow, right? So that's usually what I have to deal with. Yeah, adjacent in memory. So I think I could be wrong here. I could absolutely be wrong here because I would be learning just like everyone else, or maybe you guys know and I don't. Um, but what I am picturing, or what I'm assuming this is going to work, or how this is going to work, is we are going to have a block of memory, and our entity is going to have some size. And so we're going to be able to just sit here in this one block of memory, be able to, allocate an entity, and then next to it, allocate another entity. And we know the size already of our entity. So this could be a custom allocator explicitly for entity, nothing else necessarily. So we're essentially like contiguously allocating this entity, but we still get to treat it as if it's a pointer, right? So my thought is it would be very similar to iterating over a non-pointer of entities. Hey Devtron, how's it going? Versus how I currently picture a unique pointer, or like just using malloc by itself works, is I might get my entity allocated here, I might get it allocated here. Maybe the next entity in the iteration gets allocated here, followed by over here, and then over here, right? So that's my current understanding. This is honestly one of the things I would do all the time, especially younger when I was working in the job, is I would just try it. I would see if I could understand it, see if I could figure out what's going on here, and maybe make sense of it. So that's kind of what I want to do here, is learn how to build an allocator, especially the modern way of doing it, because I've been aware of like standard allocator, but apparently there's a new thing called PMR memory resource. So maybe that's what we're going to want to use. Um, and then what we need to do is, I think, I'm not 100% sure. We are either going to need another vector that takes unique pointer. Hey, oh, maybe it won't even be unique pointer. Maybe it'll be what will it be? I mean, the goal, and then like here you could pass in a custom allocator, right? Custom allocator. I don't know exactly, because I don't know. I've never done this, so that's what I need to figure out. As we saw with Vulkan scene graph, they ended up overloading the new and delete operator directly, which made it possible to just straight up use unique pointer without a custom allocator. So I want to look at that. I want to look at the PMR set of libraries. There's also a PMR vector, polymorphic memory resource vector, something like that. I forget what PMR stands for. Um, and then it just occurred to me we should probably have another test here to compare against. So we have unique pointer, shared pointer. I think we also want raw. entities raw, which is something I never do. And here, what we do we resize, so entities raw. We just call new, but then that means down here we actually have to delete. Yep. You basically have to do something like this, I think. Paired unique to raw. If that does anything, I have to assume unique and raw is going to be exactly the same. My understanding of unique pointer is it's all compile time. So I would expect these to be like nearly identical. They're exactly the same. Which makes sense. Unique pointer is just is essentially syntax sugar to keep with RAII to keep your code safe. All right. So I use AI. I'm just not using it here. I might use it to help me learn to build the allocator for sure. I use AI when I'm making my game because a lot of time it's just boilerplate code that I need written. I know exactly how I want to write it, so I just tell it to write it the way I need it to. Okay, so the thing I want to look at is a PMR vector polymorphic allocator. Allocator which exhibits different allocation behavior depending upon the memory resource from which it is constructed. Since memory resource uses runtime polymorphism to manage allocations, different container instances with polymorphic allocator as their static allocator type are interoperable, but can behave as if they had different allocator types. All specializations of polymorphic allocator meet the allocator completeness requirement. So I think I don't know if this is necessarily what we need. I think the purpose of this thing here is you can have allocators for like you could have different allocators for two different vectors of the same type, and then have those two vectors be able to operate with each other. Whereas normally, what you have to do with an allocator is you pass in your custom allocator into this vector. So then, if you have another vector that is, say, vector of custom allocator 2, these two cannot operate with each other. They can't copy. You can't take like they can't do anything together because they are explicitly two different types. Whereas I think the thing this polymorphic allocator is solving is the way you use it. You can use it with two different allocators and have them interact with each other. Yeah, it might be slow. I honestly don't know. I don't know the use cases because I've never used this. I've never had a need to use it. I don't even know if this is what I need for what I'm trying to figure out. I kind of just want to do a simple, maybe it's this memory resource. Public memory functions, allocate, deallocate. I also don't know what it's going to take to do like memory alignment, things like that. What kind of issues I have to account for. Okay, so this isn't giving me an example. Memory resource. So it looks like you might have to derive from it, then override the allocate functions, new delete resource, bytes alignment, forward the actual heap allocation to the default system resource. This feels like I would have to. I would want to handle this differently. I don't even know how I would plug this into verbose resource. So you pass the verbose resource into your PMR vector. So I guess I could start simple, right? I could just try this real quick. Allocate, deallocate. It's not saying, okay, it does say it's virtual. So I guess that is its intention. So we need to derive from memory resource for our allocator. Yeah, I like using AI as well. I also like coding. The one of the things I have observed in myself, the more AI I use, and if I'm not careful and I don't pay attention to what it's generating, or if I like I start to like not care, right? I'm like, generate, boom, that's good enough, you know. And then it's like it generates hundreds of lines of code, and it feels like work. It's like, oh man, I got to do a code review. I gotta reassess what it's doing and tell it to fix things. And it gets to a point where it's like, man, it it produced close enough the answer I wanted. I'm gonna move on. So I find that I start to not care, and I start to like mentally lose track of what's happening under the hood. And so it's like, oh, I gotta slow down, make sure I get all the foundational pieces in place before I start like having AI spit stuff out on top of it. So yeah, the cognitive debt, right? And so I always want to make sure I have things like in line. It becomes a lot more stressful, honestly, professionally if you're using it, because at least for me and the work I do, like I'm on the line. Someone is paying me money to give them code that they expect to work and do what they expect it to do and be, be maintainable, extensible, all that fun stuff, right? And so if I'm using AI to like generate a bunch of stuff, then I'm really starting to panic because it's like, oh no, is that actually how I expect, like is it doing what I actually expect it to do? Or or what? So for personal projects, toy projects, things that I'm working on the side, yeah, I'll just have AI spit stuff out and like, it's good enough. But for like the professional work, I'm like, I don't know. I'm not sure. Okay, so I guess this is where I need to start. But I wasn't looking to use a whole new vector type though. But it looks like this type of vector is what you would use to pass in your allocator. That way you can use. Okay, I think I see what's happening. Predefined standard resource. So there's even, oh, it even has a monotonic buffer resource, fast arena style allocator that takes space from a stack buffer and grows monotonically without individual deallocations. Useful for local temporary processing. Maybe we try this. Synchronized pool resource, unsynchronized pool resource, thread unsafe chunk allocator that separates memory into pools of identical bucket sizes to drastically reduce fragmentation. So I'll be honest, if I was going to implement an allocator myself and I wanted to like keep the pointers stable when it grows, I was thinking of just like cheating and using a standard deck or something like that. But this kind of sounds like that's what that is, except the memory chunks are probably a lot larger because a deck is only like 16 bytes at a time or something. I don't remember how big a deck is. Synchronized pool resource, thread safe variant of the unsynchronized pool resource. So I wonder if that means that you can allocate and deallocate on different threads. Hmm. Hmm. think I am interested in trying this unsynchronized pool resource. Okay, so where's the header file? What's the header file for all this? Memory resource. Also, what version of the language standard did all this come out in? 17? I've never used this stuff before. Memory resource. Then we need to standard PMR monotonic buffer resource. So I guess monotonic means it doesn't grow. It's statically defined. What does that mean? I don't even know what that means. I have to assume it does introduce the Good night, Parul. Have a good night. Thanks for stopping by. My PC specs are have I shown that on stream before? I feel like I've shown that. I have two PCs. I'm on a different computer right now. Maybe I can show you guys real quick. Think. Nope, I always do this. I don't have my desktop set up for can I change? Well, actually, wait. Can I change the desktop? How do I do this? You guys are watching me be incepted here. Stand by. Stop. Display capture. There we go. Oh, my camera all the way over here. Let's do this. Wait, why is that there? Oh, I don't have this set up. Hang on. We're gonna fix this live. Okay, so this is my desktop background, right? That didn't work. Why did that not work? My desktop back. Wait, what's happening here? I don't know. All right. Anyway, that's what I have right here. This is what I have. I have an Intel. What is that? 5950X with 64 gigs of RAM, multiple drives. What is this? A RTX 3090 Ti, which turns out only lets me like handle streaming so many things at once and recording. So my other computer actually has a an AMD GPU, which honestly lets me like stream to YouTube and Twitch and vertical and record the video all at the same time while keeping the GPU usage under like 80%. But on this computer with the 3090 Ti, as soon as I start to record, my GPU pegs to 100% and there's a lot of stuttering. I use Linux professionally. Personally, I mostly stick to Windows just because it's a lot easier to do everything I need to do, especially when I'm like playing games or playing with friends. Um, that kind of thing. It is very possible I have some settings that are wrong. Yes, you're right. I just know that on my other machine, the GPU, the AMD GPU, the what is it, the 70, I don't even know what I have anymore, the 70 something XT, whatever the good AMD GPU is, it has more decoders, I think, or encoders, so I'm able to do more with it than what I could do on the 3090. But yeah, I don't know. I'm also on a 1440p display. but Twitch only supports 1080. So I like if I wanted YouTube to have a higher resolution, I can't share the same encoder. So I have to split the encoders out. But when I do that, that's when I was getting the 100% GPU usage with recording. Because the recording also used its own encoder. So yeah, but yes, I'm almost certainly doing stuff wrong. I have not spent a lot of time and effort like figuring out configuration for all of this. Baldur's Gate music? Sure is. That's not quite what I wanted. Okay. Okay. So what is this monotonic buffer resource? Special purpose memory resource class that releases the allocated memory only when the resource is destroyed. It is intended for very fast memory allocations in situations where memory is used to build up a few objects and then is released all at once. Okay, that could make sense. If you are this is actually kind of cool because if you're building an application and you know exactly what all you're going to be allocating, super fast. So let's try this because we know exactly what we're going to be allocating, right? Now, I don't think for something like Awin as a dynamic game engine, this is the answer. But I am just curious, performance wise, if this improves like the pointers. So let's try this real quick because I have never used this before. How do we even use this? Oh, it even has a benchmark function. Funny. Test function. Oh, it's even like comparing benchmarks. So there's a PMR list, monotonic buffer resource. What? Polymorphic alley. Okay, so I have to do all of this. Probably. They're not defining a size for it though. Does it have like a default buffer size? I mean, only one way to find out. Let's try it. Okay, so we need a PMR monotonic buffer resource. We need a PMR polymorphic allocator of type entity. And then we need a PMR vector of type. Oh. How does that work with unique pointer? This might not be what we need. This really is only for if your bottleneck is like allocating deallocating, then it sounds like this is what you want. Dang it. I don't think this is what we need. Use PMR memory resource for make unique? Question mark? Okay, yeah. We're gonna have to create our own allocator, it looks like. And we would have to do what we would have to do what Vulkan does, Vulkan scene graph does, which is overload the new and delete operators to make use of our allocator in order for it to just work with unique pointer. So what we can do, here's what we can do. We already determined that raw pointer is exactly the same as unique pointer. So I think without having to like write a bunch of new code here, I can just do something like this, right? Where I instantiate this polymorphic allocator and then have it create a new object of type widget, stick that in a vector, iterate over the vector, and then just call delete on the object at the end of the loop and see if there's any difference whatsoever. So I think we do size of buffer. This is a buffer resource, so it doesn't own the memory. Is that what it's saying? We have to pass in our own memory? That's interesting. Let's try it. Okay. So we need what do we need? We need standard array buffer of type standard byte. I think that makes sense. Except we want to support up to how many entities? Million, I think. Oh, yeah. 1,000,000 entities times size of entity. Does that make sense? That makes sense. That makes sense, right? Yeah, that makes sense. Then here we pass in our buffer, our memory buffer. So this is kind of cool because we would be able to see. Oh, we also have to be careful because there is a stack limit, and this array is on the stack. Um, this will be funny if I overload the stack. That'll be hilarious. Or yeah, cause a buffer overflow on the stack. Stack overflow. Stack overflow. Stack overflow mentioned. All right. So monotonic buffer resource. We pass in. What do we have to do? Where was that? The allocators of type standard byte. That makes sense. I think. This also assumes the Gemini is correct. And then we're going to use the allocator to instantiate our object. C++20 provides new object for C. Okay, so we do have this for C++20. Then we just have a raw pointer of entity. Okay, so we don't even need the PMR vector here, I don't think. So this is going to be called like standard vector entity. Yeah, entities PMR, I guess. That's fine. Oh, we'll try it later. Okay. So entities PMR. So then here we resize it. Here we don't allocate one. We do what it says, dot new object entity. Then down here, destroy? I thought it was like... Where should we put it? Be to here. Do it after raw. PMR. All right, first try. Let's go. Come on, I knew it'd be too easy. What header file is byte under? Is it like... I can do this. Wait, what is it? Standard byte is under C standard def. All right. Boom. See, I remember things. I'm not gonna lie, I'm getting so hungry, and it's 8 o'clock. So let's see if we can figure out how this stuff is looking. I'd rather just probably just end it rather than pause to eat. Byte is not a member. Oh, you know what I did wrong? You guys see what I did wrong? I know what I did wrong. All right. I mean, that compiled. Entities PMR. Moment of truth, I guess. This will be interesting. I think this will be very interesting. I hope. And it crashes. Holy shit. Holy shit, guys. Holy shit. Hey, Bob. Bob Ross. You here to paint us a soothing, calm picture? Holy shit, guys. Using this PMR allocator, this very easy to read code, it is nearly as performant as just pure data. Holy shit. That is freaking awesome. What's even more awesome... Wait a minute. Was I looking at the wrong thing? Hang on. Yeah, no. Iterations per second. So we're looking at the baseline, which is 1800, 1900 frames a second, right? For a million entities. So if you want to use pointers for a million entities, it's 1600 frames a second. So it's very nearly the same amount of performance. Very nearly. That's kind of cool, actually. That's actually kind of really cool. Holy shit. So, oh man, I want to explore this more. Oh no. I can't be up all night either. Maybe we continue this Monday as well. But the other thing I want to look at doing now is actual polymorphism using this stuff, and does it make a difference, right? Because there is a downside to just having a struct of entities here. We can't do any polymorphism here, right? Like there's no polymorphism. But here we absolutely could. I just don't know what the implications are Um, let's try. What can we do real quick before I call it? I want to introduce a virtual table lookup, which would have a pretty significant impact. Actually, no, we need to keep this here like this for our baseline. But even this alone should have an impact on our baseline. But then down here, what I can do is make this size of monster, I guess. Make this monster. Making sure I'm not like... There is another downside I'm realizing. You have to kind of know what you're doing now. You have to pay attention to how you're allocating stuff, I think. I wonder if we'll have to worry about alignment at all, or if this will take care of all that for us. So this is a type monster. So we're introducing a virtual table lookup here in order to call update. So I'm curious if this will be significantly slower. The other thing I want to compare against is raw pointer. This is really what we need to compare it against, because it uses a regular allocator. Let's see, raw. And I would expect this to become a little slower. We'll leave. We make everything monster now? I guess we do. We delete. We allocate. We delete. Our baseline remains the same. Okay, it's definitely slower. But to be fair, even the baseline is slower. That's crazy. So just by introducing a virtual pointer to our, to be fair, a fairly tiny object, 4 bytes, right? If you did we talk about the consequence of making a destructor virtual on your object, like the size of your object? Does everyone know that? Yeah, everyone know. Just nod your head and say yes. Um, you're literally adding a pointer to this object under the hood. And a pointer, at least on these systems that I'm working on, is 8 bytes. Okay? So, ooh, someone said no. That's fair. You know what? Let's show this real quick. And I can show it by how do I show you guys? What's the best way to do this? I don't have a way to the problem is the Celery main. I need to replace it. I don't know why can I not go to documents? That is so annoying. Celery.h Celery main is just this. So this is what we want. We'll replace it with this. Perfect. Okay. In fact, I can probably move this up here. Okay. So the consequence of virtual, I'm going to move that back actually. Struct object, right? And we'll go ahead and give it an integer, maybe, if it'll... Why is the autocomplete not doing what I want it to? It's being a jerk. Okay. We will print. Okay. And I will comment this out so that we can just look at this. Standard print line size of object. All right. So we kind of already had this conversation on a previous stream. We all know what the size of this object is going to be, right? 4 bytes. Okay? Now, when we start using polymorphism, inheritance in C++, typically, almost always, you want a virtual destructor. And do we know why that is? If we have a derived type that derives from object, and I call if I call new derived, and then I delete this object, what do we think is going to happen if this wasn't virtual? We have object destroyed, and let's say we put our destructor here, right? And say derived is destroyed. What do we think is going to print when we call delete on our object that we allocated? We allocated derived on the heap, but we stored it as its base pointer, which is fine. Like that's how we get to benefit from like polymorphic interfaces. When I run this, object gets destroyed. So our derived destructor is never called. So we have effectively leaked memory into my computer once again. You know, I'm noticing a pattern here. You guys are causing me to leak memory in my streaming computer all the time. So anytime I have a bug or I'm leaking memory, it is almost certainly your guys' fault. So how do you fix this? Virtual pointer. By making your destructor virtual, we add a virtual pointer to our object. So literally, it's like for C++, a lot of what C++ does for you, and honestly, this is probably like I get why a lot of like C heads, like super low level programmer heads, they have a problem with C++, is because a lot of what C++ is doing, it does for you. It makes it easier for you, but then you lose sight of what it's actually doing. So then you need someone like me to have a conversation with you about what it's actually doing under the hood. So by making this destructor virtual, we are literally adding another member variable to our struct, to our class, which is a pointer, which is 8 bytes on this system. But by doing so, the compiler is able to use that virtual pointer to locate the destructor of our derived type. So even though we're deleting our object of type object, it can use that virtual pointer to find the destructor. So then when I call or when I run this code, you'll see derived is destroyed, the derived destructor is destroyed or called, and then the object destructor is called. And look at the size of our object now. It's 16 bytes. Holy crap. Didn't I just say that adding a virtual pointer adds 8 bytes to our object and our size is 4 bytes? So what's happening here? Why are we at 16 bytes? I feel like I feel like I'm in what's that movie called? I feel like I'm in Groundhog Day. I'm like my streams are starting to repeat themselves. It's that memory alignment again, right? So we add 8 bytes
as essentially like a under the hood, behind the scenes member variable, we add an 8-byte pointer. Our class is of type or size 4 bytes, but 12 bytes doesn't align to 64. 16 bytes does. So it ends up adding extra padding so that we can align to that 64 byte word that our compiler makes use of, our CPUs make use of. So that's kind of what's happening. So if I'm correct here, which I should be, right? Then what I should be able to do is add another member variable to this object. Ooh, but I'm grabbing size of object. So let's, before we jump into derived, let's do that here. So I should be able to add another member variable to fit inside that padding that was added for us and not change the size of our object. At least that's my current understanding. Yeah. So it's still 16 bytes. Or if I really wanted to, I could, instead of 4 bytes, maybe I want to add 4 individual bytes. Bool 1, 2, 3, 4. Still 16 bytes. All because we add this virtual table, this pointer to a virtual table to our object. You're hilarious, Joe. Freaking hilarious. Okay. So that explains why we are starting to see performance degradation on our entity object itself. Even though we're not storing it as a pointer, it became larger. It became essentially 16 bytes instead of 4 bytes, just by adding a virtual destructor. So, where were we? We were in the middle of building. So with that understanding, we should be able to read this table a little bit better to understand what's happening. Yeah. So we were originally seeing that 1 million entities was processing at about, what, 2,000, almost 2,000 frames a second. Now it's down to 600 frames a second, just by increasing the size of our entity, by adding this virtual, the virtual pointer, the virtual call, right? Just by doing that. So we significantly lose performance. Now, on the plus side, our PMR object, which is our derived object here, monster, it still performs very nearly just as well. And it's a derived class. So we're literally like needing to, and we're storing, actually, am I lying to you guys? I might be lying to you. Ooh, okay, so remember this. I don't know the answer here. So we're going to find out together. The performance of this is around 550 frames a second, so fairly close to the entity baseline. The issue is we're not forcing, I don't think we are forcing a virtual table lookup here because we're calling update directly on monster. What we need to do is call update on entity and have it use that virtual table to perform a lookup on the correct update function that's being called. And so the way we're going to do that is by setting this back to entity. So that was my B. This needs to be entity. We still want this. We still want our underlying buffer to be the size of monster in case we want to support derived types, not just the base type, I think. I literally learned this today, so I'm guessing here. So now, by using the entity base type, but we are still instantiating via the derived type, this should force us to perform that virtual table lookup to get to the update function. I don't know if there's going to be a performance difference or not. Holy shit, there's a... Well, no, that was already slow. Okay. So not a negligible difference, at least for the current implementation. I have other things we can explore, because the other thing I want to look at with all of this is a pointer-based entity component system, which is a lot easier, like object-oriented entity component system, a lot easier to mentally like hold in your head versus database, which is very like rigid in how you have to do things. But yeah, so we're still looking at very similar performance characteristics for 1 million entities. Now, everyone remember, this is not how you actually go about figuring out a solution for like an actual application or game or anything you're implementing. This is just for fun. This is just exploration and understanding like the performance impact of memory kind of thing. Because as you guys saw, even having data tightly packed together, just adding 8 bytes to it reduced performance by 3. But none of that really matters because you are probably not iterating over 1 million entities. And if you did have to do something like that, you're probably going to have to come up with a different solution if you're going to be like doing a lot, right? And it's not just 1 million entities. Keep in mind, it's 1 million entities over the course of 10, I don't remember exactly, samples and iterations. I don't remember exactly. I think this is 10 frames, essentially. Okay, so this is kind of cool though. I have never, like, I have been vaguely aware of what these things are. I've just never used them. I've never had a need to use them. So the other thing I wanted to try, which, oh man, I gotta end it. I need to end, guys. It's getting late for me. I'm hungry. I want to keep going though. So, dang, what do I do? Discipline, Funin, discipline. All right, guys. I want to keep exploring this. I want to make more complex types, because we'll start to see that the more complex these objects get, the less important it is that the memory is laid out as it is, because it just depends on our access patterns. And at least for iteration, this is fine. The other thing I want to start benchmarking too is the allocation and deallocation, right? Deleting entities, adding entities to a vector, and see what the performance characteristics are, because I think that's where we'll really start to see the benefits of a memory pool, is allocating, deallocating, and it'll do it very quickly. And then the other thing I wanted to look at, hopefully I won't forget, but I want to look at that, what was it, unsynchronized? What was it? Unsynchronized. PMR unsynchronized. Yeah, unsynchronized pool resource. General purpose memory. Oh, yeah. The unsynchronized pool resource. So I want to take a look at that as well. So we'll see. All right, I think I'm gonna call it there, guys. This was kind of fun. This type of stuff is what I really enjoy doing with like C++ in my free time, is just tinkering and trying to learn, because maybe I will figure something out here that'll click in my head and be like, oh, I can take this back to my client, professionally speaking, take this back to my client and be like, hey, I actually have a new way to solve this problem we've been dealing with, and it's going to save us loads of time and loads of memory, right? That's how I improve and how I've gotten better over the course of years, is doing stuff like this. So I'm really excited about this. I probably will Monday. Remind me Monday, but I will also make sure I get this pushed up to GitHub and make it open source so that if anyone else is curious, you can pull it down and do what you want with it. Maybe I'll add CMake presets to it if it makes sense to do so, that kind of thing. But yeah. All right, guys. Have a good night. Take care. I will see you next time. Bye.